Hi everyone, this is part 3 or the last part regarding the discussion on ellipse. So for part 3 or the last part, we'll be talking about graphing ellipse, both centered at the origin and not at the origin. So just as we can write the equation for an ellipse given its graph, we can also graph an ellipse given its equation. So to graph ellipses centered at the origin, we use the standard form, this one. X squared over a squared plus y squared over a squared is equal to 1. So a is greater than b for horizontal ellipses, and x squared over b squared plus y squared over a squared is equal to 1, such that a is greater than b for vertical ellipses. So how to sketch the graph given the standard form of an equation for an ellipse centered at 0, 0. So 0, 0 meaning the ellipse is at the origin. So here are the steps. So use the standard forms of the equations of an ellipse to determine the major axis, the vertices, the co-vertices, and the foci. So if the equation is in the form x squared over a squared plus y squared over b squared is equal to 1, where a is greater than b, then the major axis is the x-axis. You already know that one. The coordinates of the vertices are plus minus a, 0. So the vertices are the endpoints of the major axis. The co-vertices or the coordinates of the co-vertices are 0, positive, negative, b. So those are the coordinates of the endpoints of the minor axis. The coordinates of the foci or the fixed points are positive, negative, c, 0, which I have already given you the formula on how to get the foci. So if the equation is in the form x squared over b squared plus y squared over a squared. So earlier that was the graph is horizontal. Now this is for the vertical graph of an ellipse. So this time the major axis is the y-axis because it's vertical. So the coordinates of the vertices are 0, positive, negative a or plus minus a. The co-vertices are positive, negative b, 0. The foci are 0, plus minus c, since again this is vertical. And for c, we use this formula. C squared is equal to a squared minus b squared. So after knowing that one, all you need to do is simply to plot the center, then the vertices, the co-vertices, the foci in the coordinate plane, and draw a smooth curve to form the ellipse. So example. So graph the ellipse given by the equation x squared over x squared over 9 plus y squared over 25 is equal to 1. Identify and label the center, vertices, co-vertices, and foci. So here we have the solution. First is we need to determine the position of the major axis. So because 25 is greater than 9, here, as you can see, 25 is greater than 9. So therefore, the major axis is on the y-axis. So therefore, the equation is in the form x squared over b squared plus y squared over a squared is equal to 1. A squared will be under y squared because it is greater than b squared. So b squared, it's already given, that's 9. A squared is 25. So it follows that the center, So the center of the ellipse is 0, 0, meaning it's at the origin. The coordinates of the vertices are, since this is a vertical graph, this is 0, positive, negative, a. So in order to get a, we need to get the square root of a squared. And the square root of a squared is 5, because the square root of 25 is 5. So the coordinates of the vertices are positive, negative, 5, meaning 5 units going up, then 5 units going down. The coordinates of the co-vertices are plus, minus, or positive, negative, b, 0. So since we are given b squared as our 9, we solve for the square root. So the square root of 9 is simply 3, positive, negative, 3. So that means for your semi-minor axis, that's 3 units going to the right and 3 units going to the left. Now all that's left is to solve for the value of c. So using the formula, c squared equals plus minus square root of a squared minus b squared. So we know that a squared is 25 and b squared is 9. So subtracting, that is 16, and extracting the square root, that is positive, negative, 4. So therefore, the coordinates of the foci are 0, positive, negative, 4. We know that the foci is located on the major axis, and since the major axis is vertical, so that's 4 units going up, then 4 units going down. So we plot the center, vertices, co-vertices, and foci. So the ellipse will look like this. So this is how the graph will look like. The center, 0, 0, that is at the origin. And since this is a vertical ellipse, our major axis is on the x-axis, our minor axis is on the x-axis. So the vertices or the endpoints of the major axis are 0, 5, 0, negative 5, that's 5 units up, 5 units down. For the minor axis, the vertices, the co-vertices, I mean, are 3, 0, negative 3, 0, that's 3 units to the right, 3 units to the left. And for the foci, that's 0, 4, 0, negative 4. So that's 4 units up, then 4 units down. So that is the graph of the ellipse given the equation x squared over 9 plus y squared over 25 is equal to 1. So notice, because a squared is 25 and the square root of 25 is 5, so that's why we move 5 units up, 5 units down. And since b is 9, so the square root of that is 3. So that's why we move 3 units to the left and 3 units to the right. And since this is at the origin, so meaning the center is at 0, 0. So let's have this one. So example 4, graphing an ellipse centered at the origin from an equation not in standard form. So meaning this is in general form. Graph the ellipse given by the equation 4x squared plus 25y squared is equal to 100. So rewrite the equation in standard form, then identify and label the center, vertices, and co-vertices and foci. So for the solution, first, we use algebra to rewrite the equation in standard form. So in order to transform this one into standard form, we simply divide the whole equation by 100, since we need this side right here, or c, to be equal to 1. So dividing the whole equation by 100, we'll get 4, this part right here, 4x squared over 100 plus 25y squared over 100 is equal to 100 over 100. So as a result, simplifying 4 over 100, that will be equal to x over 25. That is the lowest term. Then 25 over 100, the lowest term there is 1 over 4, or simply 1/4. And 100 over 100 is simply 1. So since that is now in standard form, we now determine the position of the major axis. So because 25 is greater than 4, so 25 is our A, that is greater than 4. So the major axis is on the x-axis, meaning this is a horizontal graph. So therefore, the equation is in the form x squared over a squared plus y squared over b squared, where a squared is equal to 25 and b squared is equal to 4. It follows that the center is at the origin, 0, 0. The coordinates of the vertices, the endpoints of the major axis, that's the square root of a. So the square root of a squared, which we know is 25. So the square root of that is 5. So that's 5 units to the right, then 5 units to the left. So that's 5 to the right, 5 to the left. And for the co-vertices, the endpoints of the minor axis, since b squared is 4, solve for the square root of 4, which is 2. So that's 2 units up, then 2 units downwards. So after that, we solve for the value of c, again using the formula. So we know that a squared is 25 and b squared is 4. By subtraction, that's 21. And solving for the square root of 21, so we cannot simplify that further, so just leave it as is. So we have there, we were already able to find the origin or the center, the vertices, the co-vertices, and the foci. Now let's graph. So here, since the center is at the origin, so we have the center at 0, 0. The vertices are 5, 0 and negative 5, 0. Since the ellipse is horizontal, we move 5 units to the right, then 5 units to the left. Then for the co-vertices, that's 0, 2 and 0, negative 2. That's 2 units up, then 2 units down. So if you're able to observe earlier, the value of a squared is 25. So the square root of 25 is 5. So that's why the endpoints of the vertices are 5, 0, negative 5, 0. And if you have noticed, b squared is equal to 4. The square root of 4 is 2. So that's why we move 2 units up, then 2 units down. Now for the foci, solving for c, we use the formula. So we're able to get square root of 21. And again, we cannot simplify further 21. So just leave it as it is. And if you will compute for the value of square root of 21, that's roughly around 4.6 or 4.58. So if you will be plotting that one, so that's 1, 2, 3, 4, around here, just in between 4 and 5. So also here on the left, so you can plot the square root of negative square root of 21 in between the values of 4 and 5. And after getting those, if you know the origin, the vertices, the co-vertices, and the foci. So that will be the time that you'll be able to draw a smooth curve for your ellipse. So last one right here is graphing ellipses not centered at the origin. So when an ellipse is not centered at the origin, we can still use the standard forms to find the key features of the graph. So when the ellipse is centered at some point hk, we use the standard form, this one, if the ellipse is horizontal, and this equation for a standard form if the ellipse is vertical. So from these standard equations, we can easily determine the center, vertices, co-vertices, foci, and positions of the major axis. Now, how to sketch the graph given the standard form of an equation for the ellipse centered at hk or not at the origin? Actually, it's still the same with graphing ellipses centered at the origin. It's just that the position of the center is either, it can be on the x-axis, y-axis, quadrant 1, 2, 3, or 4, as long as it's not on the origin. So let's have this one. Example 5, graphing the ellipse given by the equation. Quantity of x plus 2 squared over 4 plus quantity of y minus 5 squared over 9 is equal to 1. So identify and label the center, vertices, co-vertices, and foci. So first is for the solution, we determine the position of the major axis. So because 9 is greater than 4, as given here, so the major axis is parallel to the y-axis, meaning if it's parallel to the y-axis, the ellipse is vertical. So we use this standard form, and as given, b squared is 4, a squared is 9. So the center of the ellipse is hk, that's negative 2, 5. So going back, so this is our h, this is our k, but get the opposite sign. So if that's 2, h will be negative 2, and on the equation, if it's negative 5, k will be positive 5. Just get the opposite sign. So that's it, that's the center. Then coordinates of the vertices are h, k plus minus a, that is equal to, since h is negative 2, so for k, which is 5, you just simply add or subtract the square root of a. So the square root of a, that's 9, which is 3. So in order to get the two vertices, so just simply copy h, which is negative 2, and solve for the positive and negative sign. So 5 plus 3, that will give us 8. Then 5 minus 3, that will give us 2. So those are the two vertices. Now for the co-vertices, for the endpoints of the semi or the minor axis, so that's h, still h, then plus minus the value of b, then k. So here, since this is for the minor axis, k is constant, so we know that k is 5, and all we have to do is solve for the sum of h and the value of positive, negative b. So I know that h is negative 2, and the square root of b squared, which is 4, is equal to 2. So that is simply negative 2 plus 2, which is 0, and negative 2 minus 2, which is negative 4. So those are the two values of the co-vertices. Now for the coordinates of the foci, that is simply h, k plus minus c. So still using the formula to solve for c. So a squared is 9, b squared is 4, 9 minus 4 is 5. So that is the square root of 5. So therefore, the coordinates of the foci are 2, then 5 minus square root of 5, then 2, 5 plus square root of 5. So now we have the graph. So center is at 2, negative 5. So that is, negative 2, 5. So that is 2 units to the left of the origin and 5 units going up. So that's the origin, the center, Then for the vertices, that's negative 2, 8, and that's negative 2, 2. So that is 1, 2, 3 units up, then 3 units down. For the co-vertices, that's negative 4, 5, and 0, 5. And for the foci, that's negative 2, 5 plus square root of 5, and negative 2, 5 minus square root of 5. So 5 plus square root of 5 is roughly around 3.16. So that's just near the value of 3. So that's it. If you have any questions, clarifications, feel free to comment your questions in the comment section below, or you can also send me a private message or send your questions in our group chat. Thank you so much, guys. You take care always. Bye-bye for now.